Hello. I decided for this video I'd let you guys see me just because I look good today. That and there's a pretty picture right behind me. So, right behind me. But anyway, so to get to the point, today we're going to be talking about properties of log. We briefly went over log in my last video, and we just kind of went over what it does and what it's about, and la-di-da. But this video, we're going to go over the certain properties of log. Now, log, it has some rules to it that are unique in and of itself, but also incorporate some rules that we've used before. Now, the very first property of log, and this is something you're going to want to remember, is called change of base. Now, last time we talked about log, we said that there were two different types of log. There was complex and there was common log. Now, complex has a base that is a different number rather than 10. Common log is log base 10. Common log is also found on your calculator. So this is where the change of base will be important. Now, I'm going to write down a quick equation, and it may make sense to you and it may not, but I want you to write it down with me as well. So we have log base A argument x. Now, this log we could not put into our calculators. This is about as simplified as we can get it in most calculators. Now, I know some calculators, though, if you do log with a different base, you can do that. But generally speaking, most calculators only have common log, which is log base 10, or log base e, but that's different. So anyway, how we would change this is with the change of base, to where you can work it with your calculator. So we would use common log. That's log base 10. This is the log that's found on your calculator. And we would do log of x over log of a. Now, this is going to give us a single solution that is going to be the exact same solution as this. Now, why this is important is, like I just said, this cannot go into your calculator. This can, and it'll give you the same answer as this. So let's go ahead and take an example with this. So let's do log base 6, 15. Alright, this, we all know you can't set it into your calculator. But I want to figure it out because my math book is kind of dumb and it has this problem for me. So I would just take log of 15 divided by log of 6. Now, this is going to give us a finite solution. It's going to give us an answer we can definitely deal with. For most of us, up until now, this was the best answer we could get. This was the most simplified we could be. But now, if you take this and just plug it into your calculator to humor me real quick, you take this, you get the answer of 1.5. That's rounded because there's quite a few numbers after this decimal. So, as we just showed, the change of base is important because it brings a complex log down to a common log that we can work with our calculator and get a definite answer. Now, the next one that I want to go over is the product property. Now, product it's an easier property of log to deal with. The change of base is probably going to be the most complex property you'll have to deal with, but the change of base is also the most widely important. So the product log is simply this. I'll do a quick equation and then we'll do an example to follow it. Now, this is where we have a product of a log, and log plus a log, that equals a product for those that aren't cultured in math, such as I. Now, whenever we have two bases that are the same, generally this is going to be with your common log, log base 10, the one you can use on your calculator. Whenever we have two of the same bases and these logs are adding up, now you have to remember the base part. That's important for this, otherwise it won't work. You can simply do log a xy. So now, instead of having this big old log problem, you just have one simple log that you can deal with in your own equation. So let's take another example, and let's do log. I'm just going to do common log because I want to be able to put this into my calculator. So log 6 plus log 15. Now, if we just plug this into our calculator, log 6 plus log 15, we'll get 1.95 rounded. So we've got definitely more decimals. Now, with here, you're multiplying x times y. So we could put a dot there to show the multiplication. Now, 15 times 6, or 6 times 15, is 90. Now, if we were to do common log of 90 in our calculators, we get the same answer, 1.95, and then a bunch of other numbers. So this just shows that you can simplify a log, two logs being added together, to make one quick and easy log and get the same exact answer. Now, let's go over another property of log. The third property I want to go over is the quotient property. Quotient is a big old cool word, and definitely one you want to use in Words with Friends if you can. And what this is when a log is subtracted from another log. So we have, let's do log a x minus log y base a. Now, at this point, this gets really confusing because, you're wondering, oh man, do I have to bring these to simple numbers and such and blah, 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 blah. But we can actually simplify this to an even easier solution. Now, the base, once again, has to be the same. It has to be a here and a here. Generally, this will be with common log, the log you use on your calculator. Now, I'm just going to use a because sometimes you might get thrown a different base. Now, instead of having x minus y, you have x over y. So let's take another example. Let's say log of 6, and I'm doing common log again so I can put this into my calculator. Log of 6 minus log of 15. Now if you just plug this into your calculator, you're going to get negative 0.39 rounded. So you'll definitely have some more answers there. But if we were to simplify this, just as our solution here says, we could take log of 6 over 15, which simplifies to log of, I think it's log of 0.4. So log of 0.4. Now this ends up equaling the exact same answer, negative 0.3 rounded. So for quotient property, if you ever have a subtraction, you just want to put the first number above the second number and divide it out to make a simple equation. Now then, to go over our last and final property of log is the power property. I've got the power! Alright, you guys probably don't want me to hear me sing. Now, the power property, we've all dealt with powers, and log is the inverse of powers. Now, what happens if we put a power on a log? So now we have an easier way of seeing this so you can plug it into your calculator. Was you have your log, and then you raise this to a certain power. Now that seems confusing, and this is difficult to plug into your calculator. I'm not even going to beat around the bush. If you can, all props to you. But if you simplify this, you end up with n times log of ax. Now, all we did here was we moved this n that was here all the way around, and we just drug it around to the front. And then we just multiplied this equation in the parentheses by n. So if we take another example, we would have log of 6 to the power of 15. Now if you want to plug this into your calculator, you want to do it like this. So you want to do log, and then in parentheses you want to put your 6, and then the little caret, and then the 1/5. This is just how you plug it into your calculator, like this. Now, this you'll end up with 11.67 with a non-terminating decimal, so it's rounded. Now, if we were just to go 15 times log of 6, once again, I'm using common log so I can plug this into my calculator just real easy like. This is going to end up being 11.67 as well. So you want to go back through this video and rewind and see my equations, and you definitely want to jot these down. I mean, if you can remember them just off watching the video, you've got to be close to Superman or Mark Gradecki. But if you want to go back and see these equations and write them down, so that way, well, you don't end up failing the class. I mean, if you don't know log, it's not like you're going to fail right off the bat, but this is really important to know during algebra and trigonometry, even up through calculus. So, until next time, keep working on math. Math, not meth.